Hey guys, I'm Matt, a developer from Ohio. In this video, I'll be walking you through the Choose Your Own Adventure project. To complete this project, you'll need to be familiar with nodes, linked lists, parent-child relationships, and trees. Let's get started. In this project, we use a binary tree to create a Choose Your Own Adventure game with branching paths. The first story piece will be the root of the tree, and each decision will take us down one of the branches. To start things off, we'll print the line "Once upon a time" to the console. This line will always print before any other output, indicating that the story is beginning. So we'll use a normal print statement and type in "once upon a time." In this project, we'll be running our program from a terminal. Instead of running when we press save, like in other places on Codecademy, we need to actually type in the command. So we'll type in python3 script.py, as script.py is the name of our code. We can press enter to run this. The reason for running our program this way is that we will be using user input later on. The terminal is where a user will enter the decisions that move the story forward. The data structure we'll be using is a tree. The majority of our work will go into a tree node class. Each node will contain some text for the story and some other links to other nodes. Let's define the class now. So that'll be the keyword class and the name of the class, tree node. Every class needs a constructor. Like I said, each node will have some text and some links. However, only the text will be set as a parameter of the constructor. Later, we'll make a method to add child nodes. So we will define the constructor, which is the init method. We will pass in self, and then we will pass in story piece, but we won't be passing in any links. We'll need to save the story piece parameter as an attribute of tree node, which we can refer to as self in this context. So self.storyPiece equals story piece. So we're taking this parameter and saving it as an attribute. We'll also set up the empty list for child nodes. We'll call this attribute self.choices because each child will represent one possible choice in the adventure. Again, we'll be making an addChild method later to fill this in. So self.choices we're just going to set to an empty list. The root of our tree node will represent the starting point in our adventure. Each other node will represent another part of the story. We'll create a new tree node, use the string in this task's instruction as the argument for story piece, and save the new node to a variable. So a new variable, story root, will be a new instance of tree node, and into tree node we will paste this string. And that will be the story piece. Let's test it out. We'll print the story piece of this new node to make sure that it got assigned correctly. So another print statement, and we're going to print out story root.storyPiece. To run the program, we'll need to type in that command again. A good shortcut is that you can just press up on your keyboard to get your last command. When we save and run the program, we should see the string that we copied from task number 6. Our finished adventure game will let you press 1 or 2 to continue. This will pick a tree node that is a child of story root and display it next. Let's practice getting user input by getting the player's name. We'll use the input function and save the result to a new variable. The argument we pass to input is the string that prints out when we're waiting for the user's input. So a new variable, user input, is going to be equal to the input function, and we'll write a prompt in here. We'll write, "What is your name?" Now, let's print out that choice. This should echo back whatever the user enters as a name. We'll use another print statement, and we will print the user input variable. When we run the program again, the console shows the string that we passed to the input function. I'll type in my name and press enter. We can see that my name is echoed back to the console. This is how we can allow the user to make choices. Later in this project, we'll prompt the user for 1 or 2, then print out the corresponding story piece. For now, we're done with the name example, so we can comment it out. Before we can prompt the user to press 1 or 2, we need 2 more tree nodes to navigate to. Remember that our tree node class has an empty list called choices. This is the list of child nodes that represent which choices can be made from that point in the story. For example, we need to add a child node to represent 1, roar back, and another to represent 2, run to the left. We'll create a new method called addChild. This method will need to take a node as a parameter so that we can pass new tree nodes to it. So we will define addChild with self and the parameter node. Any node passed to addChild holds a piece of the story that can be chosen from this node. So we'll use the append function to add the child node to self.choices. That'll be self.choices.append the node. That's all there is to adding new nodes. Now we need 2 new tree nodes to add as children. Tasks 14 and 15 have new story piece strings that we can pass to the constructor, just like we did with story root. So choice A can be equal to a new tree node, and we will pass in this string from the instruction. We'll do the same for the second choice. So choice B equals another new tree node, and again, we'll paste in the string. These nodes aren't attached to our adventure game yet because they aren't linked to. Remember that it will be impossible to traverse to nodes without links. We can create links using the addChild method on StoryRoot. We'll pass choice A as an argument. So StoryRoot.addChild, and we'll pass in choice A. We'll do the same for choice B. So again, StoryRoot.addChild, and we'll pass in choice B. Now, take a moment to think about the structure of this tree. At the top is the root, which we've called story root. The second level has choice A and choice B. The 2 choice nodes are leaves because they don't have any children of their own. We won't be referencing choice A or choice B by name anymore. Instead, we'll rely on our tree. We can traverse the tree, starting from the root, going down 1 level at a time until we end on a leaf. Each time we land on a tree node, we'll print out the story piece and let the user pick which node to move to next. We'll need to define a new traverse method to do this. This one won't take any parameters except the usual self. So we will define traverse, take only self. As we traverse, we'll need a variable that indicates our current position in the tree. For example, it'll be set to choice A if the user presses 1 at the first prompt. When the adventure begins, the current node will be the root. Because we'll be calling traverse from story root, we can say that the current node is self. So story node is going to start as self, which in this case is going to be referencing the story root because we're going to call storyroot.traverse. We'll need to print the story piece of the current node so that the user can read it and pick one of the choices. The current story piece will always be at storynode.storypiece. So we will print storynode.storypiece. Let's test it out. We can call traverse on storyroot. We should expect it to set storynode to itself, then print out the same first story piece that we've been seeing. So that'll be storyroot.traverse, and we will save and run the code. Now that we know traverse works from the root, we can remove the other print statement that makes the same output. So we'll remove this print storyroot.storypiece because that's what we're getting from storyroot.traverse. Traverse prints the current story piece. We need it to prompt the user for 1 or 2, update story node to the chosen node, and repeat until we reach a node with no children, which is known as a leaf. To determine if the current node is a leaf, we can check how many children it has. If it has 0, then it is a leaf, and the story is over. In other words, we want to repeat the process until storynode.choices is an empty list. We can check if choices is empty by looking at its length. If the length is greater than 0, we should keep repeating. We'll use a while loop to continue repeating until the length of choices is not greater than 0. So while the length of storynode.choices is greater than 0. And all this means is that if we have anything assigned to choices, because we've used addChild, then we'll keep looping. But if this is the end of the story, it won't have any choices to make, and we can go ahead and exit the while loop. For any node that isn't a leaf, we need to prompt the user to enter 1 or 2. We'll use the input function, just like in the name example we did earlier. We'll save the result as a new variable. So we'll call this variable choice, and that will be input with the string enter 1 or 2 to continue the story. We need to update the story node to a new node based on the user's input, but there's one thing we should account for. It's possible that the user inputs something other than 1 or 2. In this case, we should print an error message. We can check if the input was 1 or 2 with the keyword in. Note that we need to use the string versions of these numbers because anything returned from the input function will be a string. So if choice is not in, and we'll make a list here with the string for 1 and the string for 2. So if it's not in, meaning it's not either of those, we will print an error message, something like invalid choice, try again. Another thing to note is that if the user does get this error message, they'll be able to immediately try again because of the while loop. If the input is 1 or 2, then we can update story node. First, we'll need to convert choice to a number because the input function returns a string. So else, we will make a chosen index variable, and that will be the integer version of choice. So if you put in 1 or 2 as a string, this integer function will turn that into 1 or 2, the number. We also need to decrease the value of chosen index by 1, because the two children are located at the indices 0 and 1, not 1 and 2. Even though lists start at 0, it's usually more user-friendly to start at 1, so we show the choices 1 and 2, but we're storing the choices at 0 and 1. So we will do chosen index minus equals 1 to turn 1 to 0 or 2 to 1. The chosen child will be the node at this index in the current node's list of children. That means it's at chosen index in storynode.choices. So the chosen child is the node at storynode.choices chosen index. Whenever we choose a child node, we should print out the corresponding story piece. This will be the story piece that explains the outcome of whichever choice the user just picked. So we'll use a print statement, and we'll print out chosenchild.storyPiece. Finally, we'll update the current node to be the chosen child. Remember that the current node is determined by the variable story node. So we'll update story node to be the chosen child. Now, the next time we go around the while loop, it'll be from the perspective of this child node. This will continue down the tree, starting from the root, until we reach a leaf. The tree node class is done. Make sure you still have a call to traverse at the bottom of your program. If we save and run now, we'll be able to play the Choose Your Own Adventure game. I got an error here, and that turns out to just be on line 17 here, I'm missing an S. So if you were following along really closely, you'll need to correct that as well. All right, now that I have that fixed, we can actually test it. So this says a bear emerges from the trees and roars. Now we can press 1 to roar back. And from here, we can't do anything because that's the end of the program that doesn't have any children. We can run again and pick 2 to see the other text. And this is the text stored in these choice variables. With the system we have set up, we can just keep adding new choices as child nodes of existing choices. The next several tasks will have us do just that. We'll copy story piece strings from the task instructions and paste them as parameters of new tree nodes. We'll start with A1, which is the outcome if you select 1 and then 1 again. So a new variable, which will be choice A1, a new instance of tree node, and we will paste in the string from this instruction. Next is A2, which is the outcome if you select 1 and then 2. So choice A2 is a new tree node, and we'll paste in that string. We'll add these new nodes as children of choice A. Make sure you don't add these as children of the root. The parent of each node should be the tree node that contains the prompt. So choice A dot add child, and we'll add choice A1. And we'll do the same, copy and paste, and we'll add choice A2. If we save and run our program, we'll be able to go 2 levels deep into our tree, but only if we press 1 first. Choice A has 2 children, but choice B is still a leaf. So if we press 1 first, then we can still press 1 or 2 from here. However, if we pressed 2 first, the story would end because choice B has no children yet. To fill out our game, we'll add 2 last nodes, starting with B1. This is the outcome if you select 2 and then 1. So choice B1 is another new tree node, and we'll paste in the string from the instruction. Last node is B2, which represents the outcome of 2 and then 2 again. So our choice B2 is going to be one last new tree node and paste in one last string. And just like we did previously, we'll add these 2 nodes as children of choice B, because that's the node with the story piece that leads to these outcomes. So choice B dot add child, choice B1, and again I'm going to copy and paste this to add choice B2 as well. If we save and run now, we'll be able to go 2 levels deep across the whole tree. So now, if we press 2, just like when we pressed 1 before, we'll be able to press 1 or 2 to get these different outcomes. Try to visualize the tree as it is now. There are 7 total nodes. On the first level is the root node, which is where we start traversing from. On the second level is choice A and choice B. These are on the second level because they are both children of the root node. On the third level, there are 4 nodes we added in the past several tasks. These nodes are children of either choice A or choice B. The tree we've created is a binary tree, because each node has exactly 2 children, unless it's a leaf. When a user enters 1 or 2, one of those 2 children is selected, and we move 1 level deeper in the tree. This is analogous to a more common application of trees, which is searching. When we search for one node in a tree, we don't have to go through every node, just those which are linked between the root and the target. You might even say that the adventure game is searching for one leaf, and that the user inputs are used as heuristics to guide that search. In this project, we created a binary tree data structure to store data representing a choose-your-own-adventure game. We wrote a tree node class with values and child links, then used a traverse function to move down the tree based on user inputs. Trees are an important tool in storing easily searchable hierarchical data. I'm Matt for Codecademy. Happy coding!